Okay, so now that we know how to do vector addition, we're going to do the opposite operation, which is vector resolution. And what I want you to do here is first draw and label your component vectors. Your component vectors are your x and y direction vectors. So this is your f of x, and this is your f of y. Okay? They should make the triangle with your applied force, Fa. Okay, so the situation that we're given right now is that this object, a wagon, is being pulled on a sidewalk. The sidewalk, as you can see here, is a flat horizontal surface. So the question is, which direction is the object accelerating? It cannot accelerate along the angle. It's not being lifted off the ground, okay? It is gliding along the horizontal surface. So that means it's accelerating in the horizontal direction. To the right, we know is 0 degrees. The next question says, which force, we have three forces. We have Fa, which is the hypotenuse, Fx, which is the horizontal component, and we have Fy, which is the vertical component. Which force is causing the object to accelerate? So, as you know, it's being pulled in the x direction, so that means the F of x force. So for the third question, it wants us to find the magnitude of the force, meaning just the value of the force that's causing the object to accelerate. So that means we need to find Fx. We know Fx is the adjacent side of the triangle, so we're going to use the cosine. Our hypotenuse is Fa. We multiply that by the cosine of our angle. Okay. Now we get this equation originally from the cosine equals the adjacent over the hypotenuse. This is just the rearranged equation, algebraically different, okay? It's the same thing. So plugging it in, we say 500 times the cosine of 55. Okay? That will give us a value of 286.8. I only asked for the magnitude, so we're done. The next question is asking, what's the magnitude and direction of the acceleration? We know from Newton's second law, the acceleration is the force divided by the mass. In this case, the force we're using that causes the acceleration is f of x. So we take our value from number 3, and we divide by the mass given, which was 50 kilograms. Okay, this gives us 5.7. So when we write our answer, make sure we include the direction. And since we know it's moving to the right, we just put at 0 degrees. So now let's change our scenario here, and we'll go to the left. Not much really changes except for the direction. Okay, f of x is now going to the left, but f of y is still positive in the upward direction. So which of these two is going to cause the acceleration? Well, it's going along the horizontal surface, so that means the direction is 180, and the force causing it is still f of x. Now all we have to do is find the values for f of x. 900 is our hypotenuse. We're still using the cosine function. Now you have the option. You can use 120, or you can subtract from 180 and get the reference angle right here. Either way, you get the same value for f of x. The value that we get using the 120 will be negative 450. That's okay. It just means it's going to the left. That's an accurate statement. However, all I care about for my final answer is the magnitude, so I don't need the negative. Okay, negative in physics is direction. The last thing is finding the acceleration. Take our value of the force, divide by the mass given. That gives us 6.4 for our magnitude. Don't forget the direction. We're talking about vectors here. They have two things. Okay? Great. So now that we have a basic understanding of the concept, if the object is on a flat surface, the only force causing the object to accelerate is in the x direction. Okay, let's do some more vector resolution. This is something that we already should know how to do. This is a skill that we've previously learned when we started learning about motion in 2 dimensions. Okay, so this should seem very familiar. Breaking down our vector into its components. Okay, that's the first thing we're always going to do is draw. Okay, this we know is in quadrant 1. So that means my angle, my theta, or theta r for those of you who are in my class, is 60 because the angle is the same. The 360-degree angle from 0 is going to be the same as whatever your reference angle is. Okay, that's what happens in quadrant 1. Okay, if you look at the top of your page, it gives you the equations for fx and fy. That's what I expect you to use. So, plugging in our values. If we find fx using cosine, we get 125 newtons. Don't forget your direction. Because it's going to the right, we know it's at 0 degrees. For the y, we know it's 216.5, and since it's going up, it's at 90 degrees. Okay? Quadrant 2. Break it down into your component vectors. We know that since it's in quadrant 2, we do 180 minus our reference angle to get our 360-degree angle. We're going to plug in our numbers into the same formula. X is still cosine. And you can use either angle, whatever you prefer, 135 or 45. The only difference is you'll get a negative for the x direction if you use 135. But the magnitude will be the same. If you notice that you get the same value for both x and y, you did something right. It's a 45, 45, 90 triangle, or a special right triangle. Okay, so that means it's isosceles. The legs are the same. Okay, don't forget your direction. Because it's going to the left in the x direction, it's at 180. And because it's going up in the y direction, it's at 90. Okay, next problem is in quadrant 3. I like to start always with the x direction and then draw my y direction. Just makes all of my math consistent. In quadrant 3, I know I am adding to 180. Okay, that's my 360 angle. And I'm plugging in my new numbers. Still using cosine for the x direction and sine for the y direction, right? X is the adjacent to the angle, y is the opposite to the angle. Okay, don't forget your directions. Left is 180, right is, and down, is 270. Last quadrant, quadrant 4, to the right and down. Because we're in quadrant 4, we subtract from 360 to get this angle here. Okay, because I always draw the x direction and the y direction, x will always be cosine and y will always be sine. To the right is 0. And down is at 270. Okay. Hopefully this helps you get better at your vector resolution, finding your component vectors.